All right, Math 3, 6.6 notes, solving radical equations. So the good thing about these notes, we've kind of worked with all the pieces. Now we're kind of putting it all together and solving actual equations. Okay, so first of all, we're dealing with these radical equations. Well, a radical equation, that's what goes in the blank. Radical equation is an equation that has a variable in a radicand, in other words, it's got like a square root symbol, or a variable with a rational exponent, which again is like a fractional exponent. Okay, so if we see a radical or a fractional exponent in our problem, that's considered a radical equation. Okay, so how would we solve a radical equation? So like how would we solve, for example, zoom in a bit more, square root of 4x plus 1 minus 5 equals 0. Okay, now when you're solving an equation, most of the time you can kind of think of it this way. What would you do if you plugged in a number for x? Okay, so if I plugged in, pick a number like 2, doesn't matter what it is. If I plugged in 2 for x, what would I do to that number? So what would I do first? Well, first we multiply by 4, so I'm going to put times 4 over here, so just times 4. And then we would, after we multiply by 4, we'd add 1, so then we go plus 1. And then we'd take the square root, so I'm going to put square root. And then we'd subtract 5, so minus 5. So these are the 4 things that we would do if we plugged in a number for x. Well, to solve this thing, I basically want to do the opposite of these in the opposite order. So I want to do the opposite of this, then the opposite of that, and the opposite of that, and then the opposite of that. And then we'll have our answer for x. Okay, well, what's the opposite of subtracting 5 from my equation? Well, the opposite of subtracting 5 would be adding 5. So we're going to start off by adding 5 from both sides of my equation. And then I would get the square root of 4x plus 1 equals 5. Okay. Another way to think about this, the first step we always want to do is get either the radical part by itself, or if it has a rational exponent, we want to get the part raised to a power by itself. Okay, so anyways, got that done. So check. Next, what do we want to do? Well, we want to do the opposite of square rooting both sides of our equation, which is squaring both sides, and that's going to get rid of that radical. So then I want to square both sides. And then the exponent and the radical, those are like inverses. Those pretty much cancel each other out. And we get 4x plus 1 equals 25. Okay. And then, okay, that's done. And then next I want to do the opposite of adding 1 to both sides. I want to subtract 1 from both sides. And then we'll go up here where we have a little more space. That gives us 4x equals 24. And then finally, I want to do so that's done. I want to do the opposite of multiplying by 4. I want to divide by 4. And that's going to get x by itself. So if we divide both sides by 4, we get x equals 6. And then that's our answer. Okay. Now, we're saying that x equals 6 is the solution to this equation. Now, you don't have to just take my word for it. When you get an answer like this, especially on your test, plug it in and make sure it works. And you can probably do this in your head. Let's just do a little mental math. 4 times 6, well, that's 24. Plus 1 is 25. The square root of 25 is 5. 5 minus 5 is 0. So yeah, it does work. So check, it works. And then we can move on knowing we got the problem right. Okay, so don't forget to always plug in your answers. It's just a good way to make sure you got your problem right. All right, example number 2. So again, here, what if I plugged in a number 4x? What would I do to that number? Add 5, then square root it, then add 2. And then that should equal 4. Okay, so I want to do the opposite of those things, those 3 things that we said. The last thing we said was add 2. We want to do the opposite of that and subtract 2. In other words, we want to get the radical part by itself. And that gives us the square root of x plus 5 equals positive 2. Okay, next I want to do the opposite of taking the square root of this thing, and I want to square both sides. Okay, and if we do that, we get x plus 5 equals 4. And then last step, now, if I plug in something for x, I would add 5, do the opposite of that, subtract 5, and we get x equals negative 1. Okay, and again, check your answer. It doesn't take long. If I stick in negative 1 plus 5, so 5 minus 1 is 4. Square root of 4 is 2, plus 2 equals 4. Yeah, that does work. So this is definitely our answer. Okay, moving on. Next, how do we solve an equation like this one? Now let's rewrite this so we have a little room to work. We've got x plus 3 to the 2/3 power equals 4. I'm going to leave a little bit of a gap on purpose. Okay. Now, how would I solve this problem? Now let's see, I don't want x plus 3 to the 2/3 power. I want that to go away. In other words, I just want x plus 3 to the first. Well, how can I make this number come out a 1? In other words, what can I multiply 2/3 by to make it a 1? Okay, and also, when do I multiply exponents? When I raise a power to a power. Okay, so when I get a problem like this with a rational exponent, I want to raise both sides to a certain power. That's going to make the exponent go away. And what do I want to raise this to? Well, it's always going to be the reciprocal of this number. So the reciprocal of 2/3 is 3/2. And sorry, I need to do that to both sides of my equation. Okay, so I want to raise both sides to the 3/2 power. And then these are going to reduce to 1s, and those all go away. And I end up with just x plus 3 on the left, which is perfect. That's what I wanted. Equals, and then, well, what is the, what's the answer for 4 to the 3/2 power? Okay, well, don't freak out. Just do this one piece at a time. And if you need to, you can even write this in radical form. If I have 4 to the 3/2 power, that's the same as what? So let's see, 4 to the 3/2 power. I know I'm working with 4. Okay, we'll start with that. And then what root am I taking of 4? Well, remember, like a tree, roots are on the bottom, so I want to take the second root, which is the square root, and then I want to raise that number to the power on top, which is the 3rd power. Okay, so let's see. The square root of 4 is 2. 2 cubed is 8. So then I can just replace this whole thing with 8. Okay, last step, subtract 3 from both sides. And we get x equals 5. All right, so then there's our answer. Okay, and again, check that. What's 5 plus 3? 8. What's the cube root of 8? 2 raised to the 2nd power is 4. So then, yeah, it does work. So this is our answer. Okay. So again, if you're working with something with a radical in it, get the radical part by itself. If you're working with something with a rational exponent, get that part by itself, and then raise both sides to the reciprocal power. All right, and that's what it says down here. When solving equations that look like this, so it has a rational exponent, raise each side of the equation to the reciprocal of your exponent. All right, last two on the front page here, and then we'll get to the back page. All right, so again, you can think of it as if I plugged in a number for x, what would I do to that number? And then do all that stuff in the opposite order, the opposite of that stuff in the opposite order. Or we can just think, okay, I need to get the thing raised to a power by itself. So the first thing we want to do here is divide both sides by 5. Okay, and then that gives me 3x plus 1 raised to the 1/4 power equals 2. You're going to see a lot of small numbers, especially in a problem like this, because what do we have to do next? What power do we have to raise both sides to get rid of that exponent? Well, 4. And if we use bigger numbers, like, I don't know, 7, punch in 7 to the 4th power in your calculator. Do 7 times 7 times 7 times 7. It's going to be big. It's going to be, what, 343 times 7, whatever that is. So anyways, a big number. So we're going to see a lot of small numbers, mostly 2s and 3s. Okay? And like we said, we need to raise both sides to the 4th power. You could put 4/1 if you want to, but we don't need the over 1 part. And that'll get rid of that exponent. And that leaves us with just 3x plus 1 equals 2 to the 4th. So that's just 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay? Next, subtract 1 from both sides, and we get 3x equals 15. And then divide both sides by 3. And then we're going to get over here x equals 5. Okay? And again, you can always check your answer, but yeah, that one is correct. All right, moving on. Last one on the front page. We want to solve f of g of x equals 36. Okay, so we got something equals 36, and then we need to figure out, well, what is f of g of x? Okay, so then in my function f, what is my function f? It's 4 times something to the 2/3 power. So we got 4 times something to the 2/3 power, and we know we're going to set that equal to 36. And then, again, what are we going to plug in for my function f? Instead of an x, we're going to plug in g of x, which is 3x minus 3. Okay, so now we got our equation set up. Now we can start to solve. So the first thing we want to do is get the part raised to a power by itself. In other words, we want to get rid of that 4. Well, the opposite of multiplying by 4 is dividing by 4. So we want to divide both sides by 4. Might have to write kind of small here. They didn't give us a ton of space to work this one out. Maybe I should have scooted it over. Oh well. And then that gives us 3x minus 3 to the 2/3 power equals 9. All right. Next, I need to raise both sides of my equation to whatever power is going to get rid of that exponent. So I'm going to raise both sides to the reciprocal of that number, which is 3 over 2. Okay. And then this stuff all cancels, and we get 3x minus 3 equals what? Now, keep in mind, and hopefully you've noticed already, but the nice thing about these problems is they're usually making it work out so that these numbers work out to be whole numbers when you simplify them. Okay, so remember, the 3/2 power means they want to raise it to the 3rd power and take the 2nd root. Doesn't matter which one you do first, so do the root first. It's going to keep your numbers smaller. What's the 2nd root? The square root of 9, 3, raised to the 3rd power, we get 27. Okay. Next, if we add 3 to both sides, up here where we have a little bit more space, that gives us 3x equals 30. And then finally divide both sides by 3. And we get x equals 10. So again, a nice whole number. Thus they usually make these work out pretty nice for you. Okay. All right, and we can plug it in and check, but yes, that one does work as well. All right, on the back page. Zoom out a bit so we can read this whole thing. All right, hopefully this sounds kind of familiar. Blank, a solution of a simplified version of an equation that does not satisfy the original equation. So we worked with this in the last chapter in the first semester, and that is an extraneous solution. All right, so an extraneous solution is basically an answer you get that does not work in your equation. Okay. Now, like it says here, when we raise each side of an equation to a power, it is possible to introduce an extraneous solution. Therefore, it becomes very important that you check all solutions in the original equation. Okay, now why does that happen? Let me show you real quick because it's not super hard. If we have a basic equation, let's say x plus 1 equals 3. Okay, what's the answer? Obviously, the answer is 2. Let's make a note at the top. X equals 2. Okay, what can I do to this equation? Can I multiply both sides of this equation by, I don't know, let's say 5. And then I get 5x plus 5 equals 15. Okay, so now we got a new equation, right? It's a different equation, sure. But what didn't change? Well, what's the answer to this thing? X equals 2. Okay, can I subtract 7 from both sides? Minus 7, minus 7. And we get 5x equals 8. Okay, this one's actually going to work out a little bit funky. Yeah. Hold on a sec. Let me check my work. What do I do? Still 2. Subtract 7. Subtract 7. Yeah. Why isn't that working? Might have to edit this video for the first time. Okay, anyways. I feel like I made a mistake and I'm not seeing it right now. I don't want to stare at the paper while I got you on camera. So anyways, the point is you can do whatever you want to an equation, and what's not going to change in the equation, if you do it correctly, is your answer. Okay, your answer shouldn't change. I feel like I need to cut this video short and start over on the second page. Anyways, when you square something though, let's do a really basic, really simple equation, a really easy example. If I have, my answer, x equals 2, that's actually an equation, that's fine. Okay, what if I square both sides? Then I get x squared equals 4. And when I square both sides, well, now, what's the answer to my equation? Well, to solve this, I would take the square root of both sides, and then I get x equals plus or minus 2. Okay, so is 2 still an answer? Sure, it's one of the answers, but what else is an answer? Well, now negative 2 is an answer. But does negative 2 satisfy my original equation? No. Okay, so anyways, when you square an equation, well, now think of it this way. You're going from a linear equation with one answer to a quadratic equation with two answers. Well, both those answers aren't going to satisfy your original equation. So that's why it's saying here, when you square both sides of an equation, you want to, sorry, just getting the paper lined up. When you square both sides of an equation, you want to check your answers for extraneous solutions. Okay? All right, so we got the square root of 3x plus 3 minus 1 equals x. So how do we solve this equation? Well, the same way we're doing it on the front page. Let's zoom in a little bit so we can see a little better. All right, here, add 1 to both sides. And then we get the square root of 3x plus 3 equals x plus 1. Okay. Next, I want to square both sides. Now, this isn't going to be quite as nice as the front page. Why not? Well, because now I'm squaring a binomial instead of just a monomial, instead of one number. So here, this is like x plus 1 times x plus 1. We would need to FOIL it out. Okay, and then when we FOIL it out, we would get this. Well, first of all, on the left side of the equation, we just get 3x plus 3 equals, and when I square this thing, we get x squared, plus we're going to get 2x in the middle, plus 1. Okay, so don't forget, you got to FOIL that out. Don't just square each piece. That's one of the most common mistakes in algebra. All right, and then how do we solve this new quadratic equation? Well, we want to set it equal to 0. So my x squared is already positive here, so let's keep everything on the right side and move this stuff over to the left. So if we subtract 3x and subtract 3, minus 3x minus 3, that gives us x squared minus x minus 2 equals 0. Okay, and then not last thing, but one of the last things we need to do is factor this. Let's rewrite it up here. All right, so then how do we factor x squared minus x minus 2 equals 0? Well, we know we can factor this trinomial into two binomials. Okay, we got to have x and x to get x squared. My signs have to be different to give me a negative 2, so one positive, one negative. And then what multiplies to 2 and has a difference of 1? 2 and 1, obviously. My bigger number is going to be negative, so negative 2, positive 1. Okay, so then that gives us answers of negative 1 and positive 2. Okay, so then those are my two answers. But do they both work? So then that's what we want to check, is do both these answers work? So we got to check them individually and see, does one of them work, or maybe both of them will work, or maybe neither of them will work, because it is possible to have no solution. Okay, so let's see. Let's do a little mental math here. If we stick in negative 1, 3 times negative 1 is negative 3, plus 3 is 0. The square root of 0 is 0, minus 1 is negative 1. So I get negative 1 equals, and then we stuck in x is negative 1. So negative 1 equals negative 1. Yeah, that one works. So negative 1, this does work. Now we want to check 2. Okay, if I plug in x is 2. So if we stick in x is 2, 3 times 2 is 6, plus 3 is 9. The square root of 9 is 3. minus 1 is 2. So then this time we're going to get, I'll just put it up here, 2 equals, and we stuck in x was 2. So yeah, it worked for both these answers. So both of these actually worked. You don't have to do it all in your head. You can write down the work to check your answers, obviously. We're just doing a little mental math to speed things up. Okay, so sometimes both the answers work, sometimes one of them will work, sometimes neither one of them will work. All right, let's do these last two, and we'll wrap things up. Okay. Next, check for extraneous solutions after we solve this. So first, how do we solve this thing? I want to start by subtracting 3 from both sides. So unfortunately, we're ending up with another binomial on the other side, because now we're going to get the square root of 5x minus 1 equals x minus 3. And then when I square both sides, well, again, we have to square that binomial. Okay, so I've had a lot of practice with these. I can do this in my head, but you might need to write it out twice and FOIL it out. All right, then we're going to get 5x minus 1 equals x squared minus 6x plus 9. Okay, in the middle is always going to be 2 times that times that. Just double whatever that times that is. Okay, so that's how I'm doing this so fast. All right, and then we want to set it equal to 0, so let's subtract 5x and add 1 to both sides. And then that gives us x squared minus 11x plus 10 equals 0. Doesn't matter what side the 0's on. I like it on the right, so that's where I'm going to put it. All right, and then next we want to factor this thing. So I can factor this into 2 binomials. And then let's see. I know I got to have x and x to get x squared. I know my signs are going to be the same. They're both going to be negative. So minus and minus. And then what multiplies to 10 and adds up to 11? Well, 10 and 1. Okay, so that means my answers are 10 and 1. Okay? All right, so let's see. We want to check our answers now and make sure neither of those are extraneous solutions. So if I stick in 10, let's do that first. First, if I stick in x is 10, I get a 10 right there. If I stick in 10 here, well, 10 times 5 is 50, minus 1 is 49. The square root of 49 is 7, plus 3 is 10. So I get 10 equals 10, so check. Yeah, 10 works. All right, next is plug in 1 for x. If I stick in a 1 here, 5 times 1 is 5, minus 1 is 4. The square root of 4 is 2, plus 3 gives me 5. Does 5 equal 1? No. So then 1 is an extraneous solution. We don't want that one. We only want x equals 10. All right, almost done. Last one. All right, so we want f minus g of x equals 1. So that's f of x minus g of x equals 1. Well, f of x is that, so root 5x plus 1. Minus g of x, which is 2 root x, equals 1. Okay, now this one's going to be a bit tougher than the other ones. Okay, why is this one tougher? Well, because there's 2 radicals. And can we combine these things? No, unfortunately we can't. If we were multiplying instead of subtracting, then we could combine them. Okay. All right, so here we're going to end up with a binomial on one side of the equation or the other. Doesn't really matter which one. And then we're going to have to square both sides, which is going to be a pain because we're squaring a binomial with a radical. Okay, so we could square it right now. Okay, but I'd rather have this thing by itself and maybe this thing and the 1 as my binomial. So I'm going to add, and that also gets rid of my negative there, so there's less room for mistakes. I'm going to add 2 root x to both sides. Okay, and then that gives me 5x plus 1, sorry, square root of 5x plus 1 equals, and then since these are both positive, it doesn't matter which one comes first. I'm going to go the 2 root x plus 1. Okay, all right. Now that I've got one of the radicals by itself, because that's basically our goal, to get one of them by itself, doesn't matter which, I'm just picking the bigger one. Now I want to square both sides. Okay, so if I square both sides, well, the left side's easy. I just get 5x plus 1. And the right side's a little bit harder. So here, if we FOIL this out, the first thing I would have is 2 root x times 2 root x, which is going to be 4x. Again, you might need to write it out and work it out, but you're going to get 4x. Okay, and then you're going to get 2 root x times 1, which is 2 root x. You're going to get that twice. So 2 root x plus 2 root x. In the middle, you're going to get 4 root x. And then you're going to get 1 times 1 at the end when you FOIL, which is plus 1. I know this, you might be wondering where these came from. If you need to, write it out and FOIL it out, maybe on some scratch paper, but then this is what we would get. Okay, and then next we want to combine like terms. Okay, and we'll do that where we have a little more room up here, but we can show our work right here. And which side do we want to move things to? Okay, technically it doesn't matter, but we still have a radical in our equation. So we got one radical by itself, and then we squared both sides. Well, now we want to get this radical by itself and square both sides a second time to get rid of all the radicals. Then we can finally solve. So then I want to subtract 4x and move this over. I want to also subtract 1 and move that over. And this works out pretty nice because, well, this stuff's all gone. And then this stuff is gone too. I get 5x minus 4x is just 1x on the left side of my equation equals 4 root x. Okay. All right, now we have a choice. We can either divide by 4, get this radical completely by itself, or can I just square both sides right now? Sure, and I'd rather do that because I don't want to create fractions until I absolutely have to. Okay, and we can square this now because even if we square it now, it'll still get rid of the radical, and that's what we're trying to do. Okay, so then that gives us x squared equals 4 root x times 4 root x is 16x. Okay. All right, finally, no more radicals. Now we can work on solving this thing, which we're going to do by subtracting 16x from both sides. So we get x squared minus 16x equals 0. I know this is a long problem, but that's why there's only one of them. All right, and then now we want to factor this thing. It almost looks like difference of two squares, but that x is screwing it up. Okay, but these both have a common factor of x, so then take out an x. Now I got my two factors, and I want to see when do these two factors equal 0. We'll do it just right here. So we get x equals, well, this is 0 when x is 0. So 0 is one of the answers maybe. And this is 0 when x is 16. So 16 is maybe our other answer. But then we want to check, do those make our equations work? Okay. Let's rewrite our equation so we have a little bit of room to check. This one's kind of tight on space. So we got root 5x plus 1 minus 2 root x equals 1. Okay, if we stick in 0, what do we get? Well, 0 times 5 is 0 plus 1 is 1. The square root of 1 is 1. Minus the square root of 0 is 0 times 2 is 0 equals 1. So then check, yes, 0 does work. Okay, and then we'll check 16 in red. Okay, we'll use a different color ink so it's not so confusing, hopefully. All right, if I plug in 16 times 5 is 80, plus 1 is 81. The square root of 81 is 9. Minus, if I plug in 16 here, the square root of 16 is 4. 4 times 2 is 8. So 9 minus 8 equals 1. Yeah, that's true as well. So both of these answers actually worked. So we didn't see a ton of extraneous solutions here on this page, just one, but we do want to check for those. Okay. So again, remember, anytime that you square your equation, you definitely want to check for extraneous solutions. But really, anytime you get an answer, you should check your work anyways to make sure the answer is correct, which might help you find an extraneous solution. And then that wraps up the notes.